Okay, thank you very much. Good afternoon, everybody. Apologies on behalf of Richard, who would have liked to be here, but as you will see, we are kind of buried in project level activities at the moment, so he could not make it. So you're stuck with me. I'm going to be giving you a quick rundown on Prospect, where we are in terms of the development, especially, and the shift that we have had to make as we have moved on to a NASA-CLPS opportunity. So you've heard a lot about Prospect already today, but just to give you a quick overview of what Prospect is for those who don't know, it's quite a complex package. It has two major units. The first, called Proceed, is a drill, and the second is the Prosper laboratory, which will analyze samples taken from the drill. The drill will be capable of going down to about 1 meter depth, and it will sample the icy frozen regolith. It'll be capable of acquiring 2 different samples, although at the moment we will only be using the facility to use the smaller sample. So the 45 cubic millimeter sample, that will be passed on to the Prosper laboratory. For the previous implementation, we would have passed the larger sample onto Russian instrumentation on Lunar 27, but at the moment that facility is not going to be used on the CLPS opportunity. The whole drill unit is designed to minimize the temperature increase during sampling, because we of course want to preserve our volatiles as we do the sampling. And it includes lots of other instrumentation as well. So we have a multispectral imaging system, a subsurface permittivity sensor, and lots of temperature sensors as well as sensors for torque, etc., etc. Once we've taken the sample, it'll get passed over to the Prosper laboratory. There is something called the solid inlets system, which is the device that will receive, image and seal all of the samples in a series of ovens. We have 25 ovens in total. Those samples will then be heated up, and the gases that will be released will be analyzed by one of 2 spectrometers. We have an ion trap mass spectrometer and a magnetic sector mass spectrometer. So we can do isotopic analysis and abundance analysis for the gases that are released. We'll also be performing some ISRU demonstration experiments and analyzing the resulting products. So the goals of Prospect, we're going to be, as I said, extracting icy regolith from down to 1 meter. We will be characterizing the volatile inventory from that 1 meter profile at the south pole of the moon. We'll be determining both the abundance, the composition, and the origin of the volatiles that we will be extracting. And we will be demonstrating the first in situ extraction of oxygen from minerals in the lunar regolith. Those goals were established by the Prospect science team. Many of you are here. The development is led under ESA contract, and the drill unit is being put together by Leonardo in Italy. And the Open University is responsible for the Prosper instrumentation and the solid inlet system. The original development for Prospect was for Lunar 27, Roscosmos, and we had already passed the preliminary design review and initiated detailed design against the Lunar 27 interfaces, so including all of the testing of breadboards and the development models. You can see some of those models on the bottom right. In the bottom right in the middle, you can see the Prosper bench development model, and on the right hand side on the bottom right you can see the drill development model. So things happen, and we are no longer flying on Lunar 27, and at the start of 2022 we were lucky that we had already got some agreements in place with NASA to fly a version of Prospect called Prospect CLPS on one of the CLPS providers. So this was supported by the industrial work on how to manage the interfaces. So following February 2023, we spent a lot of time and effort in shifting all of the development from Lunar 27 onto a CLPS opportunity. This meant that we had to work with industry very closely to try to make sure that the interfaces were defined in such a way that we could be flexible and allow for as much interface compatibility as possible on the NASA-CLPS provider, which has yet to be decided, of course. So we've worked very hard with industry to reorient the running development. So not to stop things, but to keep on with the development. The industrial team have, in parallel, maintained all of their efforts to try to mature the design of Prospect units and the system, and the science team have evaluated the scientific impact of shifting onto a CLPS mission. The biggest impact will be the duration of the mission, which we will discuss a little bit later on.
X-axis sign.
That's a little video on the bottom right, which is showing the vibration testing of the engineering model for Prospect.
x-axis.
So, key features in the current timeline. We've had, as I said, the biggest impact of shifting to CLPS is the reduction of operations duration. We had 1 year of operations on Lunar 27. We're going to be dropping down to just 1 lunar day, so approximately 10 days of operations on the CLPS opportunity. This means we really have to focus on efficiency. The science team made an assessment of this reduced period of operations, and it was deemed that we can still meet all of our science objectives, albeit with a slightly higher risk, but we need to be efficient. We need to make sure that we are pre-planning operations and making sure that we are not spending too much time analyzing the results from first operations before we move on to the second one. We have to make certain assumptions. The lander provider and the interfaces will not be confirmed until early 2024, so we need to maximize the compatibility of all of our interfaces. The ESA and the Prospect Industrial team have worked to make sure that we can simplify our interfaces wherever possible. This includes data interfaces and mechanical attachments. And you've already heard from Sarah that we've worked very hard on a landing site selection. This is very important for Prospect, of course, because we're looking for volatiles. We need to land somewhere where we might expect to find them. So we've worked very hard on that with the LROC team and within the Prospect Science team as well. Quick rundown on the timeline. So coming up in the next couple of weeks, we're going to have a payload workshop where we'll be presenting interfaces towards the commercial vendors. All of the requirements from Prospect will be presented to the potential lander providers, and they'll be asking us all sorts of questions before they put their bids in. And as I said, we're not expected for that decision to be made as to who will be our lander until early 2024. In August, NASA will release their request for tender proposals in end of this year. It's expected that we might actually start to hear about who the lander provider is. At the beginning of 2026, we'll have the flight model delivery to the CLPS vendor, and in late 2026, the CP22 mission that we will be on should be launching, and we'll be going for operations. So operations, this is, how am I doing for time? Okay. So for operations, this is probably the biggest thing that we have to think about when we're shifting onto CLPS, because we will not have enough time to analyze the data coming down from one operations before we move on to the next one, which means we're going to have to prioritize and pre-plan all of our science operations to make sure that we can meet our science goals as much as possible. We've already kicked off some discussions with the science team earlier this year, and we're hoping to have an operations workshop towards the end of this year to follow up on this. We're going to be using fewer and more complete and low-risk operational sequences. So we can't afford to take many risks because we can't redo operations. We have to just push the button and hope that things work. We'll be front-loading the science as well, making sure we do the juicy science stuff first instead of just testing things out. We just go for it, and we'll take the best samples we can, analyze them, and just carry on with the operations. So the operations might be tailored to shorten the execution and the analysis and recovery times. So we might not be heating up the ovens to very high temperatures because it takes a long time to cool them off before we can proceed with the next operation. So these are all things that need to be discussed and worked on in the coming months. One other thing that we're looking at is cleanliness and contamination. We have a good contamination framework delivered from Open University, and this has been looked at by the science team earlier this year as part of the Prosper Critical Design Review. In general, it shows that the approach that we're following from the contamination perspective is good, and we should be able to have good science performance within that framework. We are still looking at this, though, to see how the sensitivity and the performance changes based on some of the assumptions that have been made in terms of cross-contamination. So if we take one sample from the Proceed, from the Prosper push tube, and a second sample, how much contamination are we expected to see, and how can we manage that within the operational profile? I think I'm running out of time, so I'm going to skip the last little bit and just go to the summary. So basically, we put a lot of effort in the last couple of months to redirect Prospect from the Lunar 27 opportunity to CLPS. The development itself is on track, and the industry have worked hard to make sure that they've maximized the compatibility of the interfaces for whoever our lander provider is going to be. We will find that out in early 2024. The Prospect Science team members have been working very hard on the landing site, which you heard a little bit earlier on from Sarah, but we do need to now start focusing on the operational impact of the shorter mission lifetime. And in parallel, we're going to work on the contamination and the volatile preservation work to make sure that we can weave that into the operations and the data interpretation. CP22, including Prospect Clips, is scheduled for launch in late 2026. And that's it. Thank you very much.